Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X researcher and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Planet X is Blue, the first stellar core. Now, in May of 2017, Scott Sion was able to photograph an object in the sun's corona through his telescope. The object looked hazy and striped at first, but some of the images were clear enough that many features about the object and its blue light-emitting surface became discernible. And after converting some of these images to higher resolution, the surface features became even clearer. These observations led to the beginning of the use of the term stellar core in reference to these objects that had been and continued to be observed in the sun's corona through images coming off spacecraft observing the sun. These objects behaved differently from solar system objects and were thus clearly solar system invaders, as they had to be coming from outside the solar system. And here is one of the first images we obtained of the object. As you can see, it is a bit hazy. It seemed to be striped, obviously blue. There seemed to be matter floating around it, some clumps of matter and some clouds around the object. We could not see many of the features when you know that this object is actually covered in groove-like structures. Then you can just almost see some of these through in this image. There are some signs that they are there, here and there. But it's only when it's converted to high resolution that it becomes clear that the whole object is covered in these grooves. But in such a large object, these are not actually grooves, these are fissures. This means that the whole surface here is fissured. You can also see that the stripes is made up of material that it appears to be shedding, because there's more of it in some places than others. And of course, there's all this material that seems to be floating around the object. There seems to be a cloud of dust that seems to be coming off the object. And you can see it looks like some kind of mountain peak here made up of this upper layer. So obviously just more material clumped together there than everywhere else. Some parts of this material seems to have cleared off completely, leaving the lower layer. But this lower layer looks intact. In other words, it's not being shed. It's just fissured, showing that this object has had to undergone expansion. And also, it means that this is the top surface of a very, very dense layer. And we can also see that this object is emitting light. This object is not just reflecting light from the sun. If it was reflecting light, it would be the same color throughout. It would be emitting the same brightness, and so it would be the same blue color everywhere. But we actually see that this part is much lighter blue than this surrounding part, all the way to the edge. If this object was reflecting light, then the bright part would go all the way to the edge. So it would be light blue all the way to the edge. It's not. So this means that this object is actually emitting light, and as it gains the ability to emit light from the surface, obviously through obtaining energy from the sun, so it's absorbing energy from the sun, and this it's becoming hotter, perhaps. We can explain it in terms of heat, but basically it's gaining energy. It's able to emit more light. So it most likely started emitting light from here. This is most likely the hottest spot on the object, therefore it's lighter blue. And the surrounding region here does not have as much energy yet, but obviously it will most likely spread outwards from the hot spot. So this region will in time get lighter blue. So the hard surface is very even, with no great changes. You can see no great change. The changes in elevation are on the layer that it is shedding. So there's a large amount of dust, and the material, even the material that it is shedding, all appears to be solid material. So there does not seem to be any liquids or gases on the surface of this object. And we can see that this material that it's being shed is just floating around. It's obviously not attracted to the objects, not attracted to the sun that is right here, very close to the object. So this means that this matter is very low in gravitational influence. It's not able to attract or be attracted gravitationally by the other objects. And later on, I discovered that that is because it's very low in energy. And so the object obviously expanded and lost that outer layer. And the fact that it's not gaseous, it's obvious it's not a gaseous gas giant, because there's no gaseous material on it. It does not seem to have an atmosphere at all. So it's not a gas giant. Now the stripes that we do see on it indicate that the object has a magnetic field. A stripes are a sign that matter is conforming to the shape of a magnetic field, which is always toroidal in shape. And as I said before, the object is emitting light, not reflecting. The blue stellar core does not have the type of surface that we would expect to see on any solid celestial object. The uniformity of the blue surface and the fact that it shows no sign of shedding as the upper layer is shedding indicates great density, and thus formation under a very strong inward gravitational force, as well as most likely being under enormous pressure from the layers of material pushing downwards upon it. That is when the upper layers were still being attracted to the center of the object. It is also not marked by large numbers of craters, suggesting that the blue surface has not been exposed for long. The fact that it seems to be a lower, very dense layer of an object suggests, therefore, that it is the core of the original object. This then suggests that this object, and therefore the other members of the system which behave so differently from other objects, in that they can hover in the sun's corona without colliding with the sun, are remnants of what was once a complete celestial object with many layers of material covering the core and a surface with uneven terrain and an atmosphere above that. This indicates that these objects have undergone a process that caused expansion and made them lose all those layers to the point that their cores were exposed. This is the observation that led to the naming of these objects stellar cores. And we see one of these stellar cores here in the sun's outer corona. This one is at least 3 times the size of the sun, possibly larger. It is a rough estimate. The size of the sun is indicated by the white circle on the occulter. So you can see this object is much larger. It is in the sun's outer corona and therefore still close enough to the sun that we can do a size comparison and estimate its true size from that. And I do explain all that in article 265 entitled Planet X, Object 3 times the size of the sun. Now, the objects that had been invading the solar system were known to absorb energy before the blue stellar core observation. This could be understood from observing the object that became known as the 2007 stellar core, which absorbed energy in the form of light from the sun as it approached and traversed the sun. An object that absorbs energy is likely to be an energy-depleted object, and thus it became understood that these objects were energy-depleted and that they used light as energy. The fact that the sun seemed to be getting darker also indicated that the sun was getting depleted by these objects. You may look at article 195 entitled Stellar Cores and the Dying Sun for more details on that, to see some of the SDO images that clearly show that the sun has become darker over the years. It also became clear to me that these objects do not obey normal gravitational law, and you may look at article 210 entitled Stellar Core Gravity Tidal and G is not constant, as they are often huge and yet hover close to the sun without a cataclysmic collision occurring. And here is the observation of the the 2007 stellar core, because it was observed in stereo B images from 2007. And here it is approaching the sun. It goes on to actually traverse the sun. I've written a lot about that. But here as it approaches the sun, it's emitting light from its outer envelope or atmosphere that is toroidal. It does not encompass the whole object, because you could see the actual core of the object through the top of this toroidal shaped atmosphere that it has. And it was obviously emitting light from it. That's why that side of the object looked pink. And then it's still emitting some light there, but not as bright. As it moved closer and closer to the sun, as you can see there, it became darker and darker. You can see there it's dark. And this indicated that it went from a light emitting mode, and therefore an energy emitting mode, to an energy absorption mode, to a light absorption mode as it approached the sun. And this showed that these objects absorb energy in the form of light. And it got to the point where it became clear to me that actually light is energy. All energy transfers occurs because photons are transferred. And with, like with all objects, this energy, this photon energy that is inside the particles of an object gets transferred through the gravitational field of an object. The stellar cores have very weak gravitational fields, so they have to come very close to the sun in order to absorb photon energy from the sun. This one was obviously in the outer corona. And a lot of them can start absorbing energy from the outer corona, but some are so depleted that they actually have to go into the inner corona to start absorbing energy. Now, so this object obviously shows that they used light as energy. And they actually showed me that energy is light. And you may look at article 183 entitled Stellar Cores Absorb Photons, which carry gravitational energy. Then thus the blue stellar core showed that the energy depleted object had aged and lost all the material in the layers above the core, but for a small amount which they also seem to shed. Thus, the aging is associated to energy depletion. In addition, the objects seem to expand as they lose energy. The shedding of material is likely to be due to the loss of gravity as energy is lost, so that the object cannot hold on to its surface layers anymore, and these expand and broke up and were shed. Thus, energy depletion becomes associated to low gravity. In addition, since the form of energy the objects absorb is light, light now becomes associated to gravity. So in conclusion, the blue stellar core observations done by Scott Sion through a telescope showed us what the objects seen in the sun's corona were really like. They were what remained of what was once a real living celestial object, and these were planets and stars. There was not much difference between a planet and a star besides the size of the object, therefore the size of the core where its energy generation took place. They had become energy depleted, which had caused them to lose their gravity, which in turn had caused them to expand in size and lose most of the upper layers of material until nothing but the core of the object was left. They had thus become dead celestial objects, which we now refer to as stellar cores. This is Dr. Claudia Albers. Thank you for watching.